Hello everyone, welcome back to Physics Friday. Today's topic is red dwarfs. Red dwarfs are one of the last stages of a star's life cycle and some of the most abundant stars in the universe, making up 70% of all stars that we've ever discovered. Yet they're extremely small. Most are about the size of Jupiter or roughly larger. And also they are our best bet to find alien life. Like all stars, red dwarfs combine elements in their core, and they will always be convective, which means that the hot gas rises to the surface and then cools down back towards the core to repeat the process. Whereas other stars will accumulate all of their combined elements in their cores. And so this is an incredibly slow process for red dwarfs, and this can take up to 10 trillion years for its full life cycle. Now, the Kepler Space Telescope has reported that at least 50% of all red dwarfs that we've ever discovered host planets that are similar to size or slightly bigger than Earth, most of which are in the Goldilocks zone, which means that if it's not too hot, that water will evaporate, and not too cold for water to freeze, but just right. Since red dwarfs are not very luminous, planets will need to be much closer than Earth's orbit to sustain life, similar to like a Mercury orbit. And this can pose a lot of problems. For example, a planet that is this close to a star is most likely to be tidally locked, which means that it shows the same face to the star as it revolves around it. This means that the side that is facing the star is going to be extremely hot, and the side away from the star is going to be frozen, and this can be very difficult for life to survive in those conditions. Another problem with red dwarfs is that they can vary in luminosity very quickly. If they have dark spots on the surface, for example, which are caused by phenomena in their magnetic fields, this can dip the luminosity up to 40%. But if it's active and it has a lot of solar flares on the surface, brightness could double in just a few minutes. And this makes it very hard to maintain a constant temperature on the planets around it. Despite all this, red dwarfs last an extremely long time, and this is a very promising quality to have. In the Milky Way alone, 5% of the red dwarfs are estimated to hold potential candidates for our next host planet. And although 5% might not seem like a lot, consider that that's 60 billion planets to choose from, in which we can build a civilization for up to trillions of years if the conditions are right. Eventually, red dwarfs will die, and as they use the last of their fuel, they shrink to become a blue dwarf, until all their fuel is used up, in which they become a white dwarf, which is approximately the size of Earth. It's a very, very dense star, and it's made up of degenerate gases. And this will cool over trillions of years to become a black dwarf, all of which all deserve their own video. Thank you guys so much for watching this edition of Physics Friday. I hope you enjoyed the video. If you did, feel free to like it, comment any questions that you might have on the video and any feedback you might have. And I hope you continue to question everything. And I will see you next Physics Friday.